I greet you students. Welcome to my channel. I'm Mr. Pascal Omosa. Today in our chemistry lesson, I want to teach you the contact process of sulfuric acid. Sulfuric acid is an important chemical that is used in the industry for manufacture of detergents, manufacture of fabrics, and also in the manufacture of fertilizers. Due to its importance, we are going to form it in our industries for these purposes. And for us to form sulfuric acid, we need the raw materials for this process. I write them, the raw materials for this process. For us to make it, number one, we need sulfur. Number two, other than sulfur, we can use the sulfides. And we also need oxygen gas for this process. So those are the two. You can use sulfur or you can use sulfides instead of sulfur. But we can also use, we also require oxygen in this process. I am going to show this process in form of chambers. In the first chamber, we are going to burn sulfur. Sulfur is fed into this chamber. But we are going to burn it in presence of oxygen gas. So in this chamber, sulfur is going to react with oxygen gas to form sulfur 4 oxide. From this chamber, sulfur fed to this chamber, and it is burnt in presence of oxygen to form a gas. This is sulfur 4 oxide gas. This gas is taken to another chamber, and in this chamber you must know that sulfur 4 oxide produced from burning of sulfur has impurities such as dust. It has impurities such as dust, and for us to remove these impurities, we are going to take it to a dryer. So this chamber, I say, this is a dryer and a cleaner. And for us to remove dust from this sulfur 4 oxide, we are going to apply electrostatic precipitation. This is the method we are going to use to remove dust. That means in this chamber, we are only cleaning the sulfur 4 oxide gas produced from chamber 1, and then we are going to take this sulfur 4 oxide that is now clean. I can use the term clean. The sulfur 4 oxide from this chamber is clean. It is taken to another chamber here. And in this chamber, I'm going to use these lines like this to show that this is a heat exchanger. This is a heat exchanger. Why are we applying a heat exchanger here? This sulfur 4 oxide, the next process will take it to the catalytic chamber where vanadium 5 oxide is used. And for vanadium 4 oxide to catalyze this process, it needs some temperature. Therefore, this gas from this sulfur 4 oxide must be heated to a certain temperature that is suitable for the reaction, for the action of vanadium. Therefore, in the heat exchanger, sulfur 4 oxide taken there is heated to a temperature that will be suitable for the action of vanadium. Therefore, this sulfur 4 oxide, after attaining that temperature, it will be taken to another chamber where we have the catalyst. So I will do like this. I have another chamber here. and I will call this chamber the catalytic chamber. Here, a catalyst, vanadium 5 oxide, is used to speed up the reaction between sulfur 4 oxide and oxygen. Here we have oxygen, so I write the equation sulfur 4 oxide plus oxygen, which is a reversible reaction to form another gas, sulfur 6 oxide gas. So that means the function of the catalytic chamber is production of sulfur 6 oxide, and this sulfur 6 oxide again is passed through the catalytic chamber. So I'll show arrows like this again into the catalytic chamber. And then from this chamber, the sulfur 6 oxide is taken to another chamber here, another chamber. And in this, we want to form sulfuric acid. If we mix this one with water, we will get sulfuric acid. But the reaction between this one and water cannot be carried out. Therefore, first, sulfur 6 oxide is reacted with sulfuric acid. We are forming sulfuric acid, but we need some little sulfuric acid to mix with sulfur 6 oxide to form a compound. So I will write the equation in this chamber. Sulfur 6 oxide gas is reacted with sulfuric acid in this chamber to form a compound called oleum. This is oleum. This is oleum. This is the reaction. That means from this chamber, the compound formed is oleum. Oleum H2, like this. This oleum, therefore, is taken to another chamber here, where it is reacted with water now for us to collect sulfuric acid. I said this gas cannot be mixed with water directly. Instead, first in this chamber, it is reacted with sulfuric acid to form oleum, and then this oleum is taken to another chamber now, which is called the dilution chamber. This one is a dilution chamber, and in the dilution chamber now, that is when we react oleum with the water. That is when we react oleum with water. So the equation for this reaction is oleum, like this, plus water, H2O, and then sulfuric acid is formed here. Sulfuric acid, 2H2SO4, which is concentrated. That means from this chamber, this is where we collect our sulfuric acid. We already have our sulfuric acid for purposes like manufacture of fertilizers, manufacture of detergents, manufacture of fabrics that are used. The contact process has pollution effects. Before I finish, the contact process has pollution effects, and the gas produced, this sulfur 4 oxide gas, is a very bad pollutant if it's allowed to go. If it's allowed to go to our environment, it will cause pollution. Therefore, what happens is that the chimneys through which this sulfur 4 oxide gas is released to the environment are fitted with what we call acidic scrubbers. And the work of these acidic scrubbers is that they are mostly bases, and because sulfur 4 oxide is acidic, is an acidic gas, there will be a reaction between sulfur 4 oxide and these acidic scrubbers like calcium hydroxide is used to form salt and water, which are not pollutants. They are neutral products and they will not pollute the environment. Therefore, this process is called scrubbing, and I've said that scrubbing is the use of bases in this process, and these bases react with sulfur 4 oxide, which is acidic, to form neutral products, which are water and a salt, which will not pollute our environment. Thank you very much. Let's meet in the next lesson.